So now let's look at the different types of attacks in cyber. So we're going to discuss these 6 malwares. We're going to talk about social engineering attacks, man-in-the-middle attacks, denial of service, SQL injections, and password attacks. Now, if you look at this, malwares basically target hosts, operating systems. Social engineering attacks would address or attack the gullibility of a human being with the help of a computer. For example, sending a fake mail or hosting a fake website. Man-in-the-middle attack would target a network and then try to capture data packets within the network, thus compromising your credentials. A denial of service attack would crash a service. SQL injection attacks would attack an application, and a password attack would attack the usernames and passwords of accounts, thus taking advantage of weak passwords and getting access to your accounts. So let's start with malwares. Malware basically refers to malicious software. The first part of malicious, mal, and the ware out of software becomes malware. Malwares are nothing but vehicles in which hackers embed payloads. Payloads could be viruses, worms, ransomwares, trojans. So they hide these kind of malicious softwares within legitimate looking softwares and they post them on the internet. People who are interested in those kind of softwares will obviously download them, and since they're looking very legitimate, they will try to install them, thus accidentally and unknowingly installing a Trojan, virus, or a ransomware on their machine. Now, most of us have done this at one point in time where we have looked at pirated software because we did not want to pay for it. And then we probably go to torrents and then search for those softwares, download them, and there's a keygen.exe over there which we have to execute. And then we have to copy that code, the exe file that comes out of the keygen, and then we have to replace it. And I mean, it's a very convoluted process. But the fact that you have to restore some code with some other code would basically mean that there is something wrong with that file. So 99% of the time, these programs would have viruses or trojans embedded within them, and it is going to affect the security posture of your computers. If you scan keygen.exes with any antivirus across the globe, they will always report them as malwares, and they will probably want to delete those kind of files. So how do these get infected? It gets infected into a system when the user clicks on a suspicious link. Now, obviously, if you think it is a suspicious link, you're not going to click on it. But you trust the link or you're compelled to click on it just out of curiosity. Let's say you click on that link, there's a redirector, it downloads an attachment from a malicious server and it gets installed on your machine. Most of the common ways a virus or a worm is spread is through USB devices. People pass around USB devices like nobody's business, and you have no idea where that device has been used before, and you plug into your machine, and if there is a virus on that USB device, it will get infected on your machine as well. Malwares are nothing but malicious softwares that pose as legitimate softwares but will have a virus, trojan, or a worm embedded within it, right? It could also be a keylogger. A keylogger is nothing but another software that is created to catch all the keystrokes that the user is making, create a copy of it and store it and send it back to the hacker. So whatever the user is typing, it will now be known to the hacker. It could be bank details, passwords, any personal information that the user might want to keep secret. We are going to look at 3 different demos here. This demo is just to showcase a couple of things. We are going to look at a keylogger, how a keylogger works, this virtual machine here, and I've already downloaded a keylogger and installed it. The idea of this demo is to showcase how a keylogger functions, right? So you can see online on the screen, we are using a free keylogger.en.softonic.com. We are on this site and you can download the free keylogger right from here. What I've done using my demos is that I've always have a keylogger running in the background to capture all the keystrokes that I've been doing whenever I'm doing any demos. So this keylogger here can actually be hidden in the taskbar, but for our demo purposes, I've kept it visible. When you click on it, it will open up and give you a basic screen where you can start navigating about the keylogger. Now you can see that on 8th, which is today, it already shows some keystrokes, applications, and some visited websites. As you can see, already been browsing using the browser over here, and which has been recorded by the keylogger in the background. And just to give you an example, if I click on this file, you will see all the keystrokes that I have been doing so far. And you can see I've gone to this, I've opened up my Mozilla Firefox. I've typed in a search keyword of free keylogger. Then I've gone on to the website howsecuremypassword.net, in which I may have tried out a few passwords myself. And then I've gone and copy pasted this URL into the browser window, and you can see all of this has been recorded. And just to emphasize on that, let's go on to another website, and let's go to facebook.com. I'm not actually going to log in. I'm just going to type in a random username. So someone at simplylearn.com and a password like ASD@1234. And I'm going to try to log in. Obviously, the login is going to fail because this account doesn't exist. But we want to see what happens in the background when the keylogger picks up the keystrokes that we have typed. So let's open up the keylogger again and go and see what is there in the keystrokes and clipboard. And you can see over here that we typed in facebook.com, enter, and then we did not type in the username. That's the difference here. We selected it from a drop down. So a keystroke logger, a keylogger, has not been able to capture that input. A keylogger in its essence is only records something that has been typed in by the user real time. Since we did not type in the username, it did not record that username, but we typed in the password, and you can see the password over here, ASD@1234. And this is how a keylogger works. It only captures the keystrokes that have been typed in real time. So if we use this exercise on our victims and they're just using drop-down menus, at that point in time, none of the data is going to be recorded. For that activity, you would need something which is known as spyware, which would capture screens, which would capture all of this information that is going on. Now, apart from just plugging keystrokes, what this software also does is, it also has a list of used applications. You can see all the applications that have booted up along with the operating system and the ones that have started up after the operating system has booted. It also has a list of the visited websites. You can see these are the websites that we have been visiting, and they have been listed right here. The last one being Facebook, login or sign up, right? So this can store history for a really long time. If I go back in time and if I look at some of the demos that I've been looking at, so on 14th of September, these were the keystrokes that I utilized when I was doing some trainings or while I was providing some demos on other topics. So a keystroke or a keylogger will store all that information and keep on recording it till you actually delete that data, or you can reset the keylogger. You can also set up the keylogger to send the email to you on as a daily report to a particular email address that you have sent. So as long as it detects the internet connectivity, this keylogger will send you an email to the email address that you have specified with all the keystrokes that it has logged. Now this is the free version. There's again a paid version for it. So you can go and visit this site and see how this keylogger functions. If I press on the X button over here, it will ask me if I want this to be hidden in the system tray. If I click on yes, it only using this shortcut will I be able to invoke this screen. So just for demo purposes, I do not want this to be hidden. So I'm going to click on no, and you can see that the keylogger is still visible over here. So that was the first demo that we are seeing. Viruses, as we all know, are destructive programs that once executed would destroy data or harm the hard disk or the partition tables. Worms, on the other hand, would be softwares that would be more of a nuisance value, where they're going to replicate themselves in such a way that they would consume the resources of a computer, thus crashing the computer and then requiring a reboot. A Trojan horse is another software that will allow a backdoor entry or a covert channel to the hacker, where the hacker in this case would then be able to gain access to the victim's machine through the covert channel or the backdoor without the knowledge and the authorization of the user themselves. Let's talk about social engineering attack. Now, this is where your people skills come into the picture. This is the art of manipulating people and convincing them to give up confidential information, either knowingly or unknowingly. So, most likely, we trust our friends, right? And we talk to them a lot. And we give out some confidential information which we would not give out to others. What if somebody is pretending to be our friend just to get this information out of us? And we trust this person, we give out that information, and we suddenly get affected because of that. Now, I'm not saying that everybody in the world does that, but it is one of the most common attacks that is experienced in the computing world. Now, social engineering attacks can be broken down into three categories. First is a phishing attack. Don't worry about that figure over there. You're actually not going to go phishing. It's basically what known as a phishing attack. Then there's a spear phishing attack, and then there's a whaling attack. All of these are types of social engineering attacks where you're targeting a user by sending out fake mails or fake websites and their gullibility into clicking on those links and then giving out information. So what is a phishing attack? It is a practice wherein a hacker usually sends fake mails which look really genuine, or hosts fake websites which also look genuine and looks like they're from a trusted source. Once you click on those links, there would be embedded scripts or embedded malwares which would then be executed, and then get installed on your machines, compromising the security of your device. These utilities could be used to steal credit card information, steal data from your computer, upload data to your computer, use your computer as a bot, and anything and everything that the hacker might want to do. Spear phishing is a variation of phishing. Now, phishing is a non-targeted attack. It is to the whole world at large. Whoever becomes a victim becomes a victim. However, spear phishing is a targeted attack. It is to a specific individual or to a group of individuals in an organization. So, it becomes a customized attack. You identify the victim, you identify the flaws that are existing over there in the organization, you identify the gullibility of the victim, create that fake mail to suit that particular situation, send it across to them. They'll click on that link and get infected by whatever payloads that you have embedded within it. Whaling is when you are targeting particularly wealthy or powerful people in the industry. So normally, when you're targeting CEOs, CFOs, high-level management people of an organization, it would be known as a whaling attack. So here the example is where the email has been received. Dear customer, your account is going to expire today. To keep your account activated, please click on the link here and proceed with the verification process. Now here the link that we see, activate.com, would be a hyperlink which is going to mask the actual URL where the link is going to redirect us. Right? Here the attack is on the gullibility of the customer, where they would fear that the account would be deactivated, and to prevent that, they would trust this email, click on the link, and then provide the information, thinking that they're just reactivating their account, but they're actually leaking their own information to the attacker. So the first thing you have to understand is banks or any organization are not going to send you any emails with a link in it asking you to reactivate or anything like that. In fact, banks proactively tell us that they are not going to call us and ask for any information. In fact, they would want us to call them on their registered number or the helpline number that they have declared on their website or on the cards that we possess. This is something very common in today's world. This is basically where the prey is the human itself. And the reason social engineering attacks are very successful is because of the gullibility factor that a human has. For example, human has something called emotions that a machine wouldn't. You could plead with a human for a password to be reset by gaining sympathy or empathy. But try doing that with a machine, those attacks are going to fail. Social engineering attacks are not only limited to those, but we can talk about phishing. Phishing is also a part of social engineering attack, where the gullibility of the user to click on that link is being exploited. In this scenario here, this is Clark. He's calling from the ID security team. That means that he is impersonating probably and then telling the victim that the system has been compromised. Please share the password with me. The victim, on the other hand, thinks that the person is trying to help her. She probably doesn't verify that person, trust that person, and then provides the password over the phone. Now here, it is fear that is being exploited because the password being compromised would clearly upset the end user for loss of data or for the computer revealing out confidential information. Thus, here she's trusting the IT security team for the password to be reset and given back to her. Then we come to the network attacks, man in the middle. This is also known as an eavesdropping attack, which literally means that you are going to listen in on to somebody's conversation. For example, in the figure, the client is trying to talk to the server, but you become a man in the middle and you try to listen in on the conversation that is going on. Now, obviously, the conversation over here may not be audio, but be data that is being exchanged between the server and the client. You just listen in, you make a copy of that data and you store it at your end. The data could contain usernames, passwords, may contain confidential information and help you compromise data. The attacking computer takes the IP address of the client. So you find out the IP address of the client. The client is not aware about this. The client is trying to communicate with the server. You spoof yourself as a default gateway or a trusted device, and the client thinks that it is through you that they need to communicate to the server, and thus they start sending data via your PC. So this attack normally happens on public Wi-Fi networks. I've seen that happening a lot, and thus I never recommend anyone using those public Wi-Fis. For example, you go to a coffee shop, they have free Wi-Fi over there, you connect to it and you start surfing, you start browsing. You are always signed into Google, Facebook accounts, your bank accounts and whatnot. And then there's a sniffer, there's a hacker who's doing a man-in-the-middle attack, capturing all that data. Now, it's not an easy attack, but it can be done. So this diagram shows where the man-in-the-middle attack has become successful, and now that the client and the server both are sending information via the attacker without knowing that the attacker is capturing all that data. So here in this example, here suppose you're in trouble and you need money right now, and you call your friend and ask for money. So here the person is calling John, telling John that they're in trouble, and they're asking for John to give their credit card number over the phone. Now this is a legitimate transaction. The friend is actually calling John and asking for some help. However, when John is providing that help over the phone with their credit card numbers, maybe the CVV number and all of that, and then the OTP at the end of it, at the same time, there could be a hacker doing a man-in-the-middle attack where they could be eavesdropping on whatever is being said or whatever data is being transferred. And once they capture this confidential data, they can then misuse that data to their own gains. Then comes the denial of service attack. The motive in a DOS attack is not to benefit monetarily, but to bring down a service for legitimate users that's just causing harm to the organization. For example, if I consume the bandwidth of to a particular website, since there's no more bandwidth left, other legitimate users who want to interact with the website will not be able to connect to the website, thus creating a denial of service to those legitimate users. Now, it may not be possible for me to use my laptop to target a cluster of servers because obviously the bandwidth at the other end would be very high. So, I would distribute my attack across multiple devices, thus creating a distributed denial of service, also called a DDoS attack. Then we come to the SQL injection, or SQL. SQL stands for Structured Query Language, which is the de facto language that is used by applications to interact with databases. So let it be a Microsoft SQL database, MySQL database, Oracle SQL. The syntax may be a little bit different, but it is still the structured query language that applications utilize to interact with the database. Now, the queries that are created by the applications need to be sanitized at the application level itself. So developers need to be very careful of how they are going to create those queries, what queries are allowed to go to the database, because a database is designed to answer queries. It doesn't know what is a legitimate query and what is a illegitimate query. If it receives a query, it is going to try to execute it and give out information. Thus, a hacker may insert malicious queries or malformed queries into a SQL server through the vulnerable application, causing a security event. So, depending on the queries that have been created, the attacker could delete some data or modify data, add data, edit it, or do anything that is malicious in nature that would compromise the integrity and the security of that database. For example, the Dunkin' Donuts, right? Except apart from being a credential attack, since they got access to the database, they could have added or deleted any information about any users that were there. As the name suggests, this attack is used to crack or get the password for user's account. Or when we say crack passwords, this is basically where somebody is trying to brute force or they're trying to guess the password and they're going to break the password, thus getting access to your accounts. There are 5 different ways passwords can be cracked. The first one is a dictionary attack, where we use every password that is possible through the dictionary. Now, this is the use of an actual dictionary. And that's one of the reasons when we try to create passwords, we are advised not to create passwords based on dictionary words, because these are easily guessable and there are lists already out there that contain all of these words. There's a tool that you can utilize, and that tool will then parse through each and every word that is in the dictionary file and then compare it to a possible password. If one of the words matches, the password has then been compromised. So if we are observing a little bit higher security where we have created a password that is not based on a dictionary word, then we want to look at other attacks like brute force. It is a trial and error method. So basically what we do is we identify how the passwords were created. For example, in today's world, the policies would be to consume in a password any of the alphabet characters A through Z, uppercase or lowercase, 0 to 9, and then special characters. And then we want to randomize the usage of these characters so that they are not easily guessable. But a brute force attack at the same time would then try every permutation and combination there is possible in the entire character set and then try to figure out the password. Now this takes a really long time and does take a lot of compute and storage power, and that's where the botnet example comes back in, the one that we saw earlier, which was used for DOS attack. But similarly, if I've infected multiple computers like this, I can then distribute this attack onto all those computers and use the entire compute power that is available to shorten the time that is required to crack the password. Now, this is 100% successful given the time that it may take. So if the time that is going to take is going to be 100 years, the attack becomes unsuccessful because during that period, the password is most likely to be changed, the technology is going to be changed, and so on and so forth. So if the password is easily guessable, this can be a very easy attack to perform. Then a keylogger, which is a similar attack to what we have seen. So a keylogger, as discussed earlier, is nothing but a software that once installed on your machine would grab each and every keystroke that the user has made and store it in a file which the hacker can later on access. So whatever you have been typing, passwords, credit card information, or anything else, all of those would be recorded and stored in a file, and that's one of the best way a password can be compromised. Then shoulder surfing. This is a physical attack rather than being a technical one. Here, you need to be physically be present when the user is typing in their password, and you actually look over their shoulder to see what they're typing and try to figure out what the password is. If they're quick typers, it is going to be a little bit more difficult. If they're slow typers, it's going to be that much more easy. And the last one is called a rainbow table. Now, passwords, when applications store them, are stored in hash format. Hash is nothing but a one-way signature that is created of the password file, of the word that is used for the password, and it is based on an algorithm. So the input could be of variable length. For example, a password could be 7 to 14 characters, but the output of a hash value would be fixed based on the algorithm that you're consuming. So most common algorithms in today's world that we utilize are SHA, secure hashing algorithms. Before that, we use MD5 or message digest. So all of these convert the passwords from plain text into a hash value and store it into a database. So if you actually attack that database to grab a password, you're going to get the hash value, not the password in clear text. And thus, in that scenario, comes the rainbow table to the rescue. A rainbow table is nothing but a file that will have a list of all possible passwords along with their hash values in the required format. So if you remember the dictionary attack was nothing but a list of words based on the dictionary that was stored in a file, and then the software was just trying each and every word against a possible password. Here, we do not have the word, but we have the hash value. So to reverse engineer that hash value, what we created is, we created a rainbow table where there would be a list of all the possible passwords and their corresponding hash values. So we then compare the hash value that we have captured and then search for that hash value in the file that you have created. The hash value that matches the corresponding word to it is the password in clear text. So these are the 5 types of password attacks.